Here is an example of the mean value theorem. Since we are doing the mean value theorem, we need to determine the slope on the interval and then check the derivative and see if the derivative ever equals the slope on the derivative. We must apply the mean value theorem to the function f of x equals x over x plus 1 on the interval -2 to 2. To do this, we need to plug each end of the interval, -2 and 2, into the equation for x. So we will get, when plugging in -2, f of -2 equals -2 over -2 plus 1, which will go to -2 over -1, which in the end will equal 2. Then we also have to plug in for 2, so f of 2 equals 2 over 2 plus 1, which will go to 2/3. Now, the slope will be the change in y's over the change in x's. So, 2 minus 2/3 over -2 minus 2. In order to reduce this fraction, we need to multiply the top and bottom by 3, which will give us 6 minus 2 over -6 minus 6, which will equal 4 over 1 over 12, -12, which will then equal -1/3. Next, we will need to find the derivative of the function using the quotient rule, which is, so we will have f prime of x, and in order to get the derivative of this function, we need to use the quotient rule, which is low d high minus high d low all over low squared, which will give us x plus 1 times 1 minus x times 1 over x plus 1 squared, which will give you x plus 1 minus x over x plus 1 squared, which will then reduce to 1 over x plus 1 squared. Now, the mean value theorem says take the slope of the secant, which is our -1/3, and set it equal to the derivative. And it should give us an x value between -2 and 2 that has a slope of -1/3. So with this equation here, the best way to handle this would be to take the square root of each side. But since we have a -1/3, we can't take the square root, which means we obviously have a problem. So we need to take a look at the graph. And just a hint, when plugging the function f of x into your calculator, make sure to put parentheses around your denominator. So this is what our graph looks like using this function, and here's where our problem is. It seems as though we have an asymptote at -1. Therefore, since the function is not continuous nor differentiable at -1, the mean value theorem cannot be applied on this interval, even though when connecting these two, -2 to 2, which is our interval, we get a slope of -1/3. It is hard to believe that either of these sections there is the same slope of the secant, but regardless, the mean value theorem says that the function must be continuous and differentiable on the interval. Since there's an asymptote at -1, the mean value theorem cannot be applied. We could have also seen that the function was not continuous or differentiable at -1 by looking at the equation. So our beginning function is right here. And what we could have done was set the denominator of the original function equal to 0 to tell if the function is continuous or not. So when we set x plus 1 equal to 0, we're going to get -1, x equals -1, which is inside of our interval. So that implies that it is not continuous at x equals -1. And since it is not continuous, we can also imply that it cannot be differentiable, because if something is not continuous, it is definitely not differentiable. Therefore, the mean value theorem cannot be applied to this function. So we just have to write a little something out that says that it cannot be done. So what I would write is, since f of x is not continuous at x equals -1, the mean value theorem cannot be applied to f of x on -2 to 2.